For this guided practice, we will be making a program that calculates Newton's second law. And the input will be the mass of an object in kilograms. And we will use the acceleration due to gravity at 9.8 meters per second squared. And the program will calculate the force weight in newtons of that object. So this example is geared more towards our pre-engineering students. So we will start in the dev compiler, file, new project, and we'll be creating a console application. And I'm going to call this Newton's second law, and this is associated with Chapter 2, although you won't find this as one of the Chapter 2 practice assignments. The skills that we are practicing are from Chapter 2. And when you name your projects, I would recommend naming them in such a way that you'll know what your programs are. Your exams are OpenNote and Open Code. And so this first exam that you will be taking at OTC will be, this proctored exam will be open internet. So if you can have or give yourself access to your projects, then you can use them to help you with the hands-on portion of the exam. And not only for testing, but in programming in general as a field, I found that I'm constantly needing to do something that I've done before in a project, and I may not remember the exact syntax, or maybe I even remember it, but it's a lot easier to copy and paste from an already existing project as opposed to having to retype everything. So in other words, story short, keep all of your projects and name them well, and I think you'll be better off for it. So I'm going to call this folder Newton's second law. Newton's. I'm creating these folders and naming them similar to the name of the dev project file as well. So creating the folder, saving the project there. And if you would get in a habit in your projects of putting your name and the date and the name of the project and then a brief description at the top. So okay, so for a description, I wrote this program will calculate the force, weight, and newtons of a body with a given mass in kilograms using acceleration due to gravity on Earth as 9.8 meters per second squared. Okay, so those of you who are not pre-engineering students, this may be foreign to you, but the equation is just F equals ma. Okay, we need our using directive. And I'm going to declare my variables here. And if you haven't read through the Chapter 2 PowerPoint notes yet, then I encourage you to do so. What you should have learned in that PowerPoint set is that when we declare a variable, and the reason we need to declare a variable is the compiler, if you want it to keep track, or the program, if you want it to keep track of a piece of data, then you have to tell it to set aside an area in memory to store that data, and then you have to give it a name so that in your program, as you have something to refer to it by. So you also should have looked at the data types and picked up the data types from your reading in Chapter 2. So there's several different data types. There's integer, float, double. We're going to use the double data type, and the reason I'm using the double data type is that it allows fractions. Integer does not allow a decimal portion or a fractional portion. So double, and why it has the name double, if you'll notice in your text, the size of the storage location of double is double what a short is, and I believe it's 8 bytes. So I'm creating a variable that I'll call mass, and then I'm going to create another variable that I'll just call A for acceleration, and I'm going to go ahead and initialize it. So that's a term you should have picked up from this chapter, is initializing a variable. When you create a variable, or when you declare a variable, you can give it an initial value, and that's what I'm doing here. Okay. Notice I've declared 2 variables in the same line, and you separate them with a comma when you do that. You could also, this works, but you could also declare them separately, and that would look something like this. But you can see the first way was maybe a little bit shorter. This way might be a little bit easier to read, so either way is fine with me. I'm going to stick with this one. Just I like shorter code. So we've declared 2 variables, one called mass, and the name of the variable is called the identifier, another term that you need to remember. So the identifier here is mass, and then this one is just A, and we've initialized it to 9.8. Okay. So now what we're going to do in this program is we want to prompt the user for what data we're expecting from them. In our first program, the only thing the program did was just display text. Now we're going to receive data or input from the user. So before we do that, we need to tell them what input the program is expecting. Okay. Notice my comments here. I'm using single line comments. This is the double line with the forward slash and the asterisk. Single line is the 2 forward slashes. Our cout statement will print to the console screen. Notice I put a space after the colon there. That's so that when the user sees this line, the text that they type will appear right here on the end. Okay, this next statement is the statement that reads data from the keyboard, and so this is new for us this week as well. And the name of this operator, notice looks like two greater than symbols. It's called the extraction operator. This is the insertion operator, inserting text to the console window. This is the extraction operator. We're extracting data from the keyboard. And I'm going to read that value into mass, into our variable. Okay. The only thing left to do is perform the calculation and then display the result to the user. And you can actually do that in a single line. In cout statements, you can have mathematical calculations. And I tend to do that if it will save me space. Notice how I'm daisy chaining these insertion operators, and this is completely legal, and it saves you lines of code. Notice also I'm placing spaces in front of some of my text. That way the displaying the variable, and by the way, what I'm doing here is I'm actually recapitulating or displaying the mass. I'm showing the user what they displayed. So this is how you display the value that's in a variable. You just type that variable in as opposed to typing in double quotes some literal string. Now if you do not put a semicolon at the end of a cout statement, you can carry it over to the next line without having to retype the word cout. So this is one of those instances where you don't have to end a particular line with a semicolon. The way your compiler will read this is just like it's white space. Okay, notice here I'm performing the mathematical calculation directly in the cout statement, and this is once again just fine. What you could also do if you wanted, you could create a separate variable, say f, and then perform your calculation in a line like this and then display f. But instead of doing that, I'm just saving a variable storage location and saving a line of code by doing the mathematical calculation directly in the cout statement. For simple programs like this, that's feasible. Other programs, that may not be the case, and you'll see in our future assignments where I will be doing that, the mathematical calculation internally in a separate standalone statement as opposed to in line with the cout statement. I'm going to attempt to run this program and see if there's any errors in it. Remember, the compile and run button is this one right here, F11. And it will ask you to save the CPP file. And something you might notice several students had problems with when you save the file, it may tell you that it can't find the file. Actually, that may have been just a problem at the school computers because we were saving the files in the My Documents folder, which was a mapped network location. So you may not have that issue. If you do have that issue, just close the project completely and then reopen the project and try to run it again. So here's my program running. Enter the mass of a body in kilograms. So let's use 1,000 kilograms, which is a metric ton. And the way the CN statement works is it is waiting to see either a space or the enter symbol, or waiting for you to either type a space or type the enter key. By hitting enter, that will end that CN statement. And here's our output. The force weight in newtons of a body with a mass of 1,000 kilograms is 9,800 newtons. Okay. Now, some formatting things. These lines are kind of smashed together. If you'd wanted to, you could add some end lines. I could put an end line at the beginning of this statement. I could also put an end line at the end of the statement. So the \n, that is called a escape sequence or escape character, and you should have picked that up from chapter 2 as well, from the notes. If you just want an empty line in your code, or I'm sorry, in your output, you can use this inside your quotes. Another way to do that is the ENDL command. So if I did this, it will do the exact same thing. Or it should. I'm going to recompile the program, run it again. Into the mass of a body in kilograms. Let's do something smaller, maybe 40 kilograms. And now you can see that there's a line of space after 40. That's what this end line is doing. And then there is another line of space after my output statement with the result, and that's what this is doing right here. Okay. Once you've completed this, send this CPP file to me on Blackboard under the Newton's second law assignment link, which should be under assignments and week 2.